Hey fellow YouTubers, this is N0AGI. I thought I'd do a multi-part video series on this web farm I had built a couple of years ago actually for my ham radio web services. And many people have asked some more details as to how I did it, or how does this work internally from a operating system software perspective. And I thought I'd do a short video series on that. So basically what this web farm does is it's a standalone unit, right? It's got 4 Raspberry Pis. It's got a 5-port switch, a Netgear switch, and then it's got the Raspberry Pis are hooked up to the switch, and the switch is hooked up to my external facing firewall, which in turn obviously is connected to my outgoing internet connectivity through the ISP. So this unit here is behind the firewall. And the purpose of its life is to serve ham radio web services that some of you might be using or are aware of from my previous videos. So this particular, I've done a video on this at a very high level some time back. And people have asked me, hey, when are you going to do another part 2 of it to go deeper? Just so to help out people who are looking at building something like this for their own internal hobbies or ham radio related stuff or whatever. But this doesn't have to be ham radio specific only, right? I mean, this can be for other web related services that you can build fairly quickly and easily. So really what this does as of today, I have close to 4 or 5 ham radio specific web services running on this cluster. Basically if you go to call.n0agi.com, it'll help you look up call signs and the licensee details, and both in a long format, in a short format, and various switches and parameters are available. So all of that service is served up by this cluster. The other one is very familiar, the dashboard web service for the mndmr.net, dash.mndmr.net if you go up there. And then there's also cubes.n0agi.com and few others that this cluster is running inside of it. The way this is structured, just quickly, and I will go into more details as we build out a new cluster for this particular video series. The top Raspberry Pi, they're all Raspberry Pi 3s by the way. The top one is the broker, and the bottom 3 are workers. So what the broker does is, this is a guy who first receives the incoming request from the outside world for the HTTP or API or JSON or whatever. That request comes into the broker first, and then inside of this broker we have a NGINX web server running. NGINX has a round-robin type of a load balancer already built into it, and what NGINX does is it checks which of these 3 Raspberry Pis should receive that incoming request, and then forwards that request over to that particular Raspberry Pi, and that will in turn return the request, and that gets relayed back to the user. So it's fairly straightforward really if you think about it. The request comes in to the broker determines which of the 3 Raspberry Pis receives a request, and the request response goes out the door through the broker. So very interesting technology. NGINX has simplified the web load balancing quite a bit. Of course there are many more more comprehensive load balancing technologies out there, including there was one that I had built in my previous job, which does not a packet level load balancing, but it does a process level load balancing. That's a different technology altogether. But what we are concerned about here is really a round robin, a basic minimal round robin load balancing technology. So we'll look into that as we build out a new cluster, and I'll show that to you shortly. And then one other piece is in the back here. This is a small inland USB Power Cradle. It's got about 10 USB ports in them that acts as a power cradle for each of the Raspberry Pi. So in the back, if you look at it, in the back the power supply goes into the power cradle, and the switch gets its power from its own wall wart. So really that's it from the physical standpoint. And let's now go take a look at how to build one of these. In fact, before we build one of these, I want to show you how NGINX is configured, so you can understand how this thing works, and then we'll build one out in our part 2. But in our part 1 in this video, I will show you some configurations of NGINX config file, so you understand how the config file is configured for each of these Raspberry Pis, including for the broker. I'll be right back. So we've seen earlier that my Raspberry Pi web farm is made up of 4 Raspberry Pis. The first one is the broker, and the second, or rather the next 3 Raspberry Pis are worker nodes. The Raspberry Pis 2, 3, and 4 are exactly identical from a software footprint standpoint, and also obviously from the physical footprint standpoint. They're all Raspberry Pi 3s. And all 4 of them run NGINX as a web server inside of them. The only difference is the Raspberry Pi 1's, its NGINX runs as a load balancer. So the configuration for NGINX and Raspberry Pi 1 is different from the rest of the 3. And all 3 of these Raspberry Pis run the required Python code, the HTML, PHP code that's required to serve up the web pages or the web servers, web services rather. So let's quickly jump over to my terminal. Let's first look at Raspberry Pi 1, and let's take a look at its NGINX configuration, and then I'll show you the rest of the 3 here. It might even actually make sense, before I go deeper into that, just to quickly go through a web page or web service that the cluster hosts. Let's use call.n0agi.com, and I can show you quickly how the responses come back from this cluster, and then you'll be able to better understand when I show you the NGINX configuration. I'll be right back. Okay, so before I show you the individual broker and the worker nodes config files and the setup, I want to show you quickly the working, the end user experience of the web service that is provided by the web farm. So to show you that, I just go into call.n0agi.com. This service here provides the user with a call sign lookup service. It's a fairly simple service, at least it provides a simple view. It doesn't have any extra baggage that you will traditionally find in a call sign lookup service out on the web. So I had intentionally made this a very simple service so people can call it from within their own applications and so forth, and yet be able to take get full value out of Callsign Details. So if you go to call.n0agi.com and hit enter, you find this usage page. It basically tells you how to use a call sign. So if you don't provide any call sign parameters to the URL, it takes you to the usage web page where it shows you how to use the service. So there's usage. There are 4 types of usage. One is a full call sign lookup. So let's do that. If you go into N0AGI.com and supply a call sign, let's do call equals N0AGI. And what that does is it goes to the broker, and the broker issues a command or forwards that request to one of the Raspberry Pi worker nodes, and then that worker node then crunches the numbers and spits out the output. Okay, so this is a quick view of the output coming in from one of the worker nodes. And you can tell from here in the bottom footer I added which worker node responded to that request. Okay, so if I go and issue the request again, it goes and now comes back with the same output, of course, because like I said, the software footprint is very similar across the 3 worker nodes. Only this time it came back from node number 2. Let's go do this again. Hit enter. This time the output is from node number 3. So if you noticed, every time you submitted a request, it took some time for the response to come back. And the reason why that's the case is that request would have been the first time that worker node was processing that request. But if I now go and hit enter again, this time the request response was really fast because node number 4 had already processed the N0AGI request or call sign request. So it stored the previous search into its cache. So every time after that for that particular day, it caches, and every worker node caches its own past searches for that given day. And then one other thing I had included as part of the NGINX behavior is to prevent any denial of service attacks. So for example, I'm currently in node number 2, and if I keep hitting F5, let's say F5, node number 3, F5, oops, that's too many requests too quick. So there's a configuration in NGINX that enables DDoS attackers to fail. So DDoS is where there's a repetitive incremental number of requests coming into your web server at a very speedy rate. And what NGINX can do is it can sense the number of requests coming in a given period of time or window of time, and then stop those requests from going through, and issues a 503 request, or a 503 response rather. Okay, so let's give it a 5-second window, and then let's try again. So there's a 5-second window between refreshes, approximately. That's too quick. Let's give 5 seconds. Okay, 1, 2, 3, 4, 5. 1, 2, 3. Let's do quick. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Let's do quick. Okay, so you get the idea. Now there are other formats, 3 other formats which you can use to get call sign information. Let's try the F equals 2, which is really that, and ampersand F equals 2. Let's do that. What that does is it gets you a formatted call sign with lat long details, so you can you get this additional information. It takes a little bit extra time to do that because it needs to resolve the address to a lat long, but anyways, that's beyond the scope of this demonstration. Let's go back to the other format. Let's just get a simple piped view with which is format equals 0. Let's do that. Format equals 0. And first time it takes a little bit time, but then it should work on that server fairly quickly. So that's a pipe symbol delimited content. Now, the purpose of this call is really, or this service is really for, let's say if you were to write your own application, a front-end application, and you need this data in the back end, you can make a call to my web service, get the data, and in a pipe delimited format, and you can do whatever you want to do with it. So that's the reason why I provide this service. So your front-end applications can take advantage of this web service. I think this is a really cool feature. I added this some time ago for a fellow ham who was interested in getting a callsign detail for his APRS service he was writing for weather data. So let's try that. You can go C equals that, and then F equals S for short, and that should get you a very short view of a very concise view of the call sign details. Let's see one more. Let's try N0BVE dance. That's his call sign. But anyway, so this is a fairly simple output that you can leverage for simple applications like a lightweight application, if it makes sense. Now let's quickly jump on to the broker node. Let me pull up my terminal window here, SSH'd into my broker node number 1, broker, that is the node number 1. And I'm currently in the NGINX folder, and and I have the NGINX config file. Let me pull that up. Maybe I don't have it. Let's pull it up here. Open with the default program. Okay, so this is the NGINX file on the broker. Okay, I'm not going to go too much into the details of various keys and setup and config, but basically I just want to call out certain sections that make sense to this load balancer and DDoS type of attacks. How do you resolve to those? So at the top, these are just cookie cutter sort of settings, and this basically says which user the service kind of runs under. And then this is kind of the basic cookie cutter stuff, so you can read up on that. In fact, this gets packed into every NGINX config file, so it's fairly cookie cutter. The real meat for the web service I'm demonstrating here, that kind of falls under here. So for example, there are these sections here that I've described. The first one is to limit to mitigate the DDoS issue, and the way you do that is to limit the number of requests the server processes in a given window, right? And the setting for that is this one here, limit underscore rec underscore zone setting, and the keyword really is this one here, rate equals some number of requests per minute. Okay. When we say 30 requests per minute, we are essentially saying there's a 5-second window between any two requests. So you guys, you need to just figure out how many seconds window you need as a gap between any two requests and plug that number in. So I just did 30 requests per minute, which is approximately 5 seconds apart. Okay. And this one here is the number of connections allowed per client to this server is 2 per minute, approximately, or thereof, or rather 2 max, 2 connections max allowed to this server, which is the node number 1. So that's pretty much a fairly well documented settings if you want to read up on Stack Overflow or wherever, or even on the NGINX website. The next two settings are they talk about if you want to deny access to a specific DDoS attacker's IP address, you can provide a deny section. In my case, I don't use it. And then we have this, there are some slow closing connections, which seems to be the new trend of DDoS, sort of an attack. And you can leverage the client body timeout and client header timeout sections, and that'll take care of the slow closing connections requests coming in. But anyways, I'm not going to go too deep into that. You are free to read up on Stack Overflow. They have a ton of great information there. So for the web farm to work, there is a section called upstream, and then you punch in the upstream section, give your section a name. You can call it whatever you want to call. I call it N0AGI underscore web farm underscore backend, and then you identify the servers that are participating in that web farm. These are local IP addresses or external facing IP addresses, whatever be it. In my case, these are local addresses. So I punch those in. There are 3 worker nodes in my web farm that are sitting behind the broker. All right, and then that's pretty much it. Once you define an upstream bucket, that bucket name will be utilized as a proxy for going forward calls. Now comes the fun part. You define a server. This is again a very standard NGINX section. You define a server for a host name. You give it a host name. In this case, it's called .n0agi.com. It listens on port 80. And then again, this is another standard section. I won't go too deep into that to prevent DDoS attacks. And then you provide these sections here to again mitigate the DDoS attacks, as I described in bullet number 1 and 2 above, which is this section here. So you basically call that out and say, use this setting for this server, and use this setting for this server's max connections and max requests per minute. So you basically identify which settings you want to apply. So the settings for this is defined up here, which is 30 requests per minute, and you basically take that name and then you punch it in or plug into this section here for that server. All right, and then finally, this is the important part. And now that we've defined a bucket, a farm with this name, right? With this name, we are going to say, hey, this server will be serviced by that web farm, okay? So through a proxy. So that's all it takes. And then for scenarios when there's a DDoS attack or when the user tries to submit more than 1 request per every 5 seconds, then that user will be serviced a 503 response, which is a too many requests response. And then basically I have a page called 503 page on my node, and that page gets serviced to the end user. All right, so and the error page 503 is that HTML. All right, so that's pretty much it. And then you close off. There are some sections in the bottom here. I will not go into those, but basically you can close off your server for your host and you're done. So basically, if you were to quickly summarize it, when a request comes in on the broker, the broker looks at this bucket, and then it takes one IP, one node at a time, checks if that node is alive. Sometimes if the node is dead or if the power is off or whatever, if the node is alive, it forwards the request to that node and waits for a response back, and the response is replied back to the user by the broker. So it does that in a round-robin fashion. It goes through in a cycle. So it goes to 201, 202, 203, and back to 201. And then it continues on with that cycle. So there's really not a special logic involved in a round-robin load balancer outside of the fact that it has to be alive. That node has to be alive and should respond to NGINX requests. Okay. All right. So that's the broker. All right. Let's go take a look at. I'm gonna pull up my Raspberry Pi node, the worker number 1 or node number 2. All right, over here, let me pull up its NGINX. This will be slightly different from the broker NGINX settings, primarily because this is just a web server that is responding to requests. It's not doing any load balancing logic. It's basically responding to a web request, a HTTP request. So this would be configured just like any other web node, a web server in your data center. Nothing fancy here. So basically, these are all kind of cookie cutter. Well, except for this here. These are all cookie cutter stuff, so you can read up on that. What I added into each of these worker nodes is some caching mechanism. I think I've talked about this when I was showing you the demo. When you request for a call sign data, and if that call sign was already discovered by that node, it caches that data into its cache for a period of, I believe, 10 minutes, if I'm not mistaken. And then after the 10 minutes, the cache is reset. And so basically what we are saying here is setting up a CGI cache with a cache key and so forth. But anyway, and you can set up your cache key and your cache path to whatever you prefer. But end of the day, this is the way you set up a cache, and you can read up on that on Stack Overflow or NGINX website. Now comes the fun part here for this particular node. There is the folder where the content is available to serve up pages, and pretty much that's it. And here's another section which talks about CGI caching mechanism. Outside of that, it's fairly straightforward, and every node, every worker node, node number 2, 3, and 4, all three of them have an exact copy of the NGINX config file. So this is the first one, the broker. It's different from the worker config files. Okay. Alrighty. So now I'm gonna show you guys some demo here. I'm gonna pull up the website again, and what I'm gonna do is I'm gonna try to resize this over here. Let me resize the screen here, and then I'm gonna resize the terminal window to, let's say, like that. I'm going to reduce this even more. Again, I'm just trying to prove a concept here. Okay, so pay close attention to the footer here. Right now, this page is serviced by node number 2, which is this guy here. Okay, and this is node number 3, node number 4 in my SSH window. Okay, this is my broker. All right, so now I'm gonna refresh this page. Just keep a note on this footer here, okay? I'm just gonna do the standard usage page. I'm gonna hit F5. That's node number 2. Let's see, F5 again, that's node number 3. F5 again, that's node number 4. F5 again, that's node number 2 again. So it kind of cycles, right? And we talked about that. Now, what if I'm going to go to node number 3 and I'm going to stop NGINX, okay? Service NGINX stop, all right? So NGINX on node number 3 is stopped. So for all practical purposes, node number 3 is unavailable, all right? Now, if I go into this web page again, let me hit F5. It goes to node number 4 automatically because the broker notices that node number 3 is dead practically, and it will not respond to HTTP requests. So it takes the next one in the line, which is node number 4, and forwards your request to node number 4. All right. So if I go F5 again, node number 2, F5 again, node number 4, F5 again, 2, 4, right? 3 doesn't respond because it's dead, right? Now let's go back here and let's go back to node number 3 and restart the service on node number 3. All right. Let's give another minute for it to instantiate everything. Right. Let's go back to our web page. Let's hit F5, node number 2, and F5 again. Node number 4, it's still instantiating, so let's give another few tries here. Node number 4, F5, F5, there it is. Node number 3 is back online, right? So now NGINX goes through node number 3 as well as part of that cyclical load balancing, round robin load balancing logic. Okay, so so this one here, this is the logic acting up for the DDoS attacks. If you were to hit refresh within that 5-second window period, the 503 page gets serviced, and what you're seeing here is a 503 page based on that DDoS attack logic. Okay. All right, so that's pretty much it. That's a quick demo of the web farm, a demo of how the broker nodes and the worker nodes are configured, and then a demo of how the web service behaves based on the round-robin load balancing behavior of NGINX. All right, that concludes part 1 of this. In part 2, it gets interesting because I'm going to show you guys how to build a brand new web farm cluster. In fact, I'll have a few pictures and a quick short video of the parts I had purchased just recently. So let me do that. Okay, so here's a quick view of in preparation for our part 2 of the series. We're going to build a brand new Raspberry Pi farm cluster, and I'll take you through the process of building it, configuring it, and then basically replicating what I demonstrated to you earlier on my current existing web farm cluster. Alright, so we'll be building this brand new, and I got all the parts. I have 3 Raspberry Pi 3s here, and I got 2 Raspberry Pi Zeros. I don't think I will be using that, but I will be pulling this one out of here. I'll be taking that out, and because that's been decommissioned as of last night, and I'll be having those 4 Raspberry Pis, and they will fit into this nice kit I purchased on eBay several months ago. One I purchased 2, and I think one is in my data center. The other is right here. We'll be using that for our new cluster. These are fairly nicely priced, and they came in from China. I think it came in about a week's time. I paid whatever $14 for a pack of 2. Anyway, so I got some SD cards. We only will need 16 gigs, but I have 264 gigs, but I have 4 16 gigs here. 4 mini USB cables that will be used to power the Raspberry Pis up. Now here's the other USB cradle, the charging cradle. This one I purchased at Amazon the other day. It's called the Tron Smart Charging Station. It's got 5 USB charging ports. It's got 2 outlets, pretty cool. And each of these 5 ports serve up 2.4 amps at 8 amps max at 40 watts. That should be plenty good for what I'm trying to do, because I will only be using 4 ports, right? And Raspberry Pi takes about 2.2 amps, something in that range, so we should be plenty good. This one here is really slick because you could use this as a standalone base for everything, and then power up your router switch with one of these outlets here. Okay, anyways, we'll do that in more detail when we go into our part 2. And here's a 1-footer Cat 6 Cat 5e cables rather, and I got this at Micro Center. This was a few months ago. I think they are actually 1.5 footers. Alright, so I think those are the parts we need. One thing that's not showing here is a switch, a network switch. I have one similar to the one I showed you in this part at the beginning of this video. I have one similar, I think it's still around. I'll go take a look at that. So we'll be reusing that one in this project. By the way, I will make sure I include the links to the NGINX config file, just a template. I'll make sure I create a dummy broker config file and a dummy worker config file that you guys can take and repurpose to your needs. And also we'll create links for these parts if in case anyone's interested. Well, anyways, so that's a quick view, and I'm definitely looking forward to part 2, and I hope you guys will join me then. We'll talk soon.